Muy buenos días, queridos asistentes, queridos estudiantes de neurocirugía y neurociencias. El día de hoy, pues, tenemos una lectura bastante especial que viene desde Alemania del doctor Rüdiger Seitz. Pero antes de presentarlo, déjenme, por favor, darle unas cuantas indicaciones. La lectura del día de hoy será en inglés sobre lo que fue el artículo publicado por el doctor Seitz, Belief, a Challenge in Neuropsychological Disorders. Y de segunda manera, pues por favor mantengan todos sus micros apagados y levanten la mano al final, al momento de hacer una pregunta y al momento para poder complementar nuestra discusión. Sin nada más que agregar, nos sentimos muy honrados por el día de hoy y quisiera darle la palabra a nuestro querido director de investigación de la SOPENN, Jesús Miguel Flores Delgado, para que pueda introducir a nuestro querido speaker del día de hoy. Jesús, buenos días.
Buenos días, Uriel. Como mencionas, es un verdadero placer estar aquí. Y también mencionarles que todo va a tener que ser en inglés para mantener una fluida comunicación y también discusión, obviamente, más adelante con el doctor. Entonces, sin más que decir, welcome everybody. I'm going to introduce you to Dr. Seitz. Dr. Rüdiger Seitz from the Department of Neurology, Center of Neurology and Neuropsychology, LVR Klinikum Düsseldorf, Heinrich Heine University of Düsseldorf in Germany. Today's reading proposes a very interesting topic entitled as Beliefs, a Challenging Neuropsychological Disorders. Thank you so much for being here, Dr. Seitz. We are very pleased to be with you today. And if you can share your slides once more, you can start whenever you like.
Okay, I hope you can hear me.
Yes, Doctor, we can.
All right, okay, so I would like to start off with thanking you for inviting me to this endeavor to have a talk via Zoom held here in Germany and presented in Peru. And I feel very much honored by the invitation, and I'm thrilled by this task and very much looking forward to discuss what I have to say today with you. And I would like to start off with saying that the matter of belief and believing has been regarded for many years as something which does not have an impact and has no belonging concerning the modern sciences. It should rather be something which is limited to personal feelings, to religion, and certainly not a topic of science. But the interest in beliefs and believing has increased recently dramatically, as we have seen in various places in the world that beliefs really are driving forces that make people behave particularly also in a way that other people cannot understand. So what I would like to convey to you today is that belief and believing have no real immediate relation to religion, but they are separate from that. And what I would like to convince you of is that believing is a fundamental brain function that is of great importance for the guidance of behavior. And so we are talking about physiology on one hand, but when we consider the normal neuropsychological functions, then it is clear that there should also be disturbances of belief formation and updating, resulting in pathological conditions. And that is what is part of my presentation and is summarized in the title of my talk, as you can see here. So if you have immediate questions, please interrupt me or give me a sign, then I would like to respond to that. Otherwise, I'll be happy to take questions after my presentation. Now, I just would like to give you an overview of the different topics which I am going to tackle in this talk. And I will start off with describing the processes underlying belief formation. And I would like to stress already at this point that we are talking about neural processes which take place in the brain. And the second part will then refer to abnormal brains, and I will give you an outlook on the role of beliefs for the formation and the evolution of societies. And finally, I will wrap up with a summary and perspectives. Now, I start off with this cartoon, which is a very simple cartoon, but which makes a very important initial step in that what I'm going to present today. That is that we are dealing with perception. And as you can see here in this schematic presentation, we have information that is contextualized in the environment. And you see black stripes, white stripes, and you see gray areas in between. And so this is the schematic, a minimalistic presentation of a visual stimulus which we perceive by our visual system. And the notion is that the stimuli are not isolated in our environment, but situated in a certain context. So we see three different types of information here in this panel. Now, the question is this something which has a meaning to me? And you will see or can imagine that as soon as you are confronted with the question, the gray areas that you see here, those which are flanked by black bars and those which are flanked by white bars, are these gray areas of similar intensity? So, and you will certainly say, yes, this is different. The gray areas flanked by black bars are stronger, have a stronger gray appearance as compared to the black, to the gray bars that are flanked by white bars. So you get a strong personal aspect in that, and you trust your perception, and you see the difference of gray in these different parts of the slide. So when you are then forced to say, well, are they really these gray areas of the same intensity? You would say, yes, they are, I believe it, and then you get a value, ascribe, attribute a certain value to this sensory perception that you have. So now we come to the important constituents or the important processes that underlie belief formation, and that is on one hand sensory perception of the various sensory modalities that we have, which is a formal extraction of information and this is aligned with a subjective value that you ascribe to this particular perception. Now, I take it one step further, and you see here these basic processes, perception and valuation, and they then are processed further in a bottom-up and top-down mode. This is indicated by the bidirectional arrows and will result in a neural representation. And this neural representation has a probabilistic notion. The perception never is 100%, but it is very much determined by the signal-to-noise ratio of the stimuli that you perceive. So it has a probabilistic notion, it is relevant, subjectively relevant for you, because you have ascribed a value to it, and this can be then taken as a neurophysiological expression of that what other people may call belief. Now, the important point is that these internal representations that are stored in the brain, and later on I will give you some indications how we can imagine this to be, these representations then guide our behavior such that actions are coded, and in parallel to the actions there is also the prediction of what these actions will come to and what the reactions of the circumstance people or the people around may respond to this very particular action. So we will have an action, we will have a prediction, and as we have this in this forward model, very likely there is the situation that there is a prediction error, which is a discrepancy between the action and prediction, or there is a congruence between the action and the prediction, and this will then tries back into the system in terms of reinforcement learning. The particular notion of reinforcement learning here is that this is something, this is not a classical learning, but this type of learning gets an emotional flavor as well, a value for the person that forms a certain belief. And if the prediction varies from that what is expected, and you have a prediction error, the belief that was held until this very point may be updated and modified. So beliefs are never static, in static representations, but are representations that are fluid and may be modulated by new information that was not anticipated before. Now, this was modeled then in a simple mathematical model, which I just would like to outline here. But the basic notion here is that perception valuation results in representations, which is then the basic for guidance of neural or human or non-human, but still primate, for instance, behavior. But this is a very interesting notion we may discuss later in the discussion. Now, from a cognitive neuroscience perspective, beliefs can be defined in the following way. Beliefs then are neural processes affording a meaning made of a perception in the light of its value for a subject. So you have the meaning, you have the perception, and you have the value or the valuation, the major constituents of belief formation. And if we, and as cognitive neuroscience defines this way, and this goes back then to Oliver Sacks, who had already been mentioned during the preparatory conversation we had, then we have these main components, and those and this definition then also results in certain consequences. The consequences are that these representations, these beliefs, have a personal probabilistic truth. It is not meant that it may be a truth statement in a global or general way, but it's more limited to the individual. So it's a personal probabilistic truth. The subject trusts the belief. It results in subjective preferences when it comes to decision making. I already alluded to the notion of prediction for future events, and this is then the framework for guidance of subjective and individual behavior. Now, in terms of reinforcement learning and in expected value, I would like to draw your attention to this animal experiment. In fact, on the right hand and the presentations in humans, reinforcement learning has the notion of reward and punishment and reward learning. And you can see here that the involvement of the basic or the basal striatum nucleus accumbens, but the emotional areas of the and basal ganglia become involved when it comes to the processing of expected value, and here dopamine comes into place, which is a basic neurotransmitter related to the reward functions. Now, this was modeled in a more general term by Carl Friston, and you see here a model which is limited by anatomical constraints, but which tries to extrapolate the notion of discrete events to continuous events, such that that single events result in more global representations that are maintained over longer time. I don't want to go into detail too much, but when it comes to cortical, subcortical, which means striatal or striatothalamic connections, then we talk about the multi-loop model, which was coined by Malone and collaborators already 25 years ago or so, stating that we have different functional units which are represented in the cortex, like the limbic loop, the associative loop, the motor loop. And the information from there then is projected down to the striatum and via the thalamus back to the cortex, in which way, in this multi-loop processing apparatus, different types of informations which are processed in different functional units at the cortical level become integrated and orchestrated by the further processing in the subcortical loops that go through the putamen, caudate, globus pallidus, and then back via the thalamus to the cerebral cortex. And just to mention it, you are also well aware that there is another loop going through the cerebellum as well. So when we talk about the processes of believing, we should always be aware of the fact that we are not talking simply about cortical functions, but we have to acknowledge that the processing of information at the cortical level always have an implication given by subcortical structures, and as I showed you in the slide before, other neurotransmitters come into play and mediate reward-related learning or reinforcement learning. Now, you have already seen this basic module underlying belief formation, but it can be developed a bit further, and this is what I'm going to show you here. The important point is that beliefs can be reported about. There is the notion of semantic coding of representation that you have. But we have to be aware of the fact that only a very small portion of the information that is being processed spontaneously in the brain with high temporal resolution and in parallel channels, that only a very small portion of this information enters the level of awareness and then can be described in verbal expressions or in terms of semantic coding. And the threshold of awareness is not a black and white threshold, but it's a fluid threshold, which very much is related to the complexity of the stimuli and the information that you are processing. When you have very simple, for instance, visual stimuli, then the awareness threshold is short. The more complex the stimuli become, the longer the level of awareness, and there is very good experimental data substantiating this notion, what I'm talking about. Now, this is a schema which shows the flow of information from the level of perception down to semantic coding. And in the center, there is the notion of representation. But representation is something which has a close link to memory functions and memory functions, so there are tight links between the processing systems which underlie belief formation and belief updating with the memory systems, which I'm showing here. So at the time of perception and valuation, there's a multifaceted encoding of the information at hand. And as long as reinforcement learning is going on, as long as actions are being coded, working memory is in place and allows us to direct our actions in an optimal way to the incoming information. Now, later on, there is the recall of information that had been consolidated, and there is the recall of spatial and episodic memory, which may be related in one way or the other to the awareness level. And certainly there is the recall of verbal memory as well, which is a very important aspect of semantic coding of beliefs, because this allows us to maintain visual traces of beliefs and beliefs content to later time points as behavior evolves and as people perhaps also grow on. Now, having said this, we have been talking about the processes, the neural processes that underlie belief formation and belief update. The other point then is, and which is of relevance, is that these representations, which may be called beliefs, as I told you, these representations differ in their belief content. There is good neurophysiological evidence that the information that is being processed by living subjects, including humans, is that we have static objects on one hand, we have events that are reflections of changes that we observe in our environment. And on the right-hand side, then there is a very human type of information that can only be processed only by humans. This is related to verbal contents and so-called narratives. Now, these different belief contents can be labeled in a different way, such that objects very much reflect an empirical type of belief category, while events that focus on the changes that we observe in the environment, and this may also imply changes in relation to objects that we handle, for instance, or interactions with other people, and they may be labeled relational beliefs, and then the third category related to narratives ends up in so-called conceptual beliefs. Important here is that, and I would like to highlight this, that the relational beliefs that describe events that we perceive may be related to tool use, and that is important to remember, that already non-human primates can interact with tools, with objects, and use objects as tools. So we have the opportunity then, and there are very well-designed experiments showing that monkeys, for instance, can develop such relational beliefs and use tools, for instance, for retrieving pellets of food. In interactions with different subjects, we also develop beliefs such that we can make predictions how certain people may act in certain situations. And we develop these ideas by observing their behavior and the relation or the relation of their behavior to ourselves. Narratives then pertain to autobiographical narratives or memory, cultural beliefs, religious beliefs, and political beliefs. These conceptual beliefs are a special type of belief, very much dependent on language functions, very much in contrast to empirical and relational beliefs, which do not depend on language functions, and thus may be summarized as so-called primal beliefs. Now, these different beliefs categories that are different by the type of information that is being processed and the belief contents is not an artificial categorization, but just as a reflection of that, what we humans, at least in certain languages, in Francophone languages and in Anglo-Saxon languages and in German, are able to differentiate. We use our language very differentiated in a very differentiated manner to describe empirical, relational, and conceptual beliefs, and we do this with the same words but in a slightly different manner. So the empirical beliefs are then beliefs that can be coded semantically with propositions like "I believe that is going to happen." In contrast, relational beliefs are something which are expressed in "I believe someone," "I believe her to say the truth," or "I believe him to move from, say, Hamburg to New York or to Peru, for instance. And the third very interesting differentiation concerning conceptual beliefs is that conceptual beliefs are expressed in "I believe in." I believe in God. I believe in democracy. I believe you can. I believe, for instance, in a certain political leader. So it's a narrative, and the expression is slightly different between these beliefs contents. And I think it's so amazing to see that the ordinary language that we use already allude to these conceptual differentiations. So when I say "I believe," it is a personally relevant perceptual experience or a concept or meaning which guides the subject's behavior. Now, the question is, where is this set represented in the brain? And I don't want to go too much into detail here, but this is a very interesting functional MRI study, and you see a number of areas involved. The yellow areas or the reddish orange areas are those areas which became activated when subjects were asked to judge sentences concerning contents that were testable, like, for instance, hamsters are more common as pets than turtles. Whilst the blue ones are non-testable belief contents, like, for instance, giving love to others is the most important thing in my life. And interestingly, four areas stood out, and they are marked with a green star, because these areas are those that became very important when it comes to certainty of holding a certain belief. So when we talk about beliefs, and those are now so-called conceptual beliefs, these beliefs are represented at the cortical level, involving different areas, and depending on the specific experimental design, you can differentiate in this example here, for instance, between the areas that become highlighted when it comes to testable beliefs as compared to non-testable beliefs. Now, you have seen this slide already before, and I think we all are convinced that the gray bars flanked by black bars are darker than those gray areas flanked by white bars. But this slide here shows that this was a delusion. This was a false belief. So the contextualized information that we perceive may lead to false perceptions or delusions, but we are convinced, without additional evidence, that our beliefs reflect the environment correctly. But as shown here in this example, this is not the case. This can be taken one step further, and this is very important with respect to the velocity information is being processed in the brain, and the so-called awareness threshold I was talking about previously. Now, in this experimental paradigm, subjects were presented with a fixation cross, and later on with a panel in which one of these squares was red. This presentation was interrupted by a blank in which the squares were at the same location, but none of the squares was red. And on the right hand part of the panel, you can see that different types of subjects were studied in this behavioral study. Subjects with a high inclination to develop delusions, and subjects with a low tendency to develop illusions. And what you can see is the shorter the blank with the squares with no red square was, the greater was the prediction by the subject that they would think that they predicted the location of the red square in the final display in a correct place. So the subjects, and those were healthy subjects, mixed up their own thoughts with their real perceptions, to a certain degree all the way through the experiment, but particularly to a greater extent when the blanking by in the experimental design was shorter. and you can see on the right-hand panel that this report of delusion was particularly high for short presentations of the squares below some 400 milliseconds. So the health subjects develop a false belief that they would predict what is going to happen when they were exposed with a blank. And the shorter the blank was, the greater was their misjudgment. So this is another example showing that perception in belief formation can be mocked in the brain, in the healthy brain already. I showed you the presentation with the gray bars and reflecting to the contextual information, but this slide here shows that there is also an important aspect related to timing of the information that subjects have to process. So this is the situation in healthy subjects. So what is the situation in pathological conditions? And you see here very clearly again our schema with perception on the left-hand side, and valuation, then the development of beliefs, then the generation of action, the transition to awareness, and the semantic coding, and on the lower part, the reinforcement learning. And at each instance of information processing, there can be a disturbance. And the disturbance in the first place concerning perception is that subjects develop agnosias, propose agnosia, somatosis agnosia as some examples. Lower on the lower part, then related to the disruption of valuation, there's the notion of alexithymia. Subjects are impaired, or patients are impaired of recognizing their own emotions and of recognizing emotions in the surrounding subjects. This is a severe deficit which has a severe implication for social interactions. Now, the disturbance of the generation of action based on prior beliefs is something which refers to the notion of apraxia. That is, the patients can move their limbs, have no paresis, but result in, but the actions that they generate are not appropriate, are awkward, and possibly also disturbed by parapractic movements. This is the notion of apraxia. Now, very down there, as the example of the disturbance of reinforcement learning, there is the notion of the so-called alien limb syndrome. I'm going to allude to this in the next slide. Now, when we have so those are neuropsychological disturbances in the closer sense. When we go from the action to the awareness of that what was going to happen, then we have two conditions that are very important in psychiatry, which is the occurrence of hallucinations, of abnormal perceptions, and the development of delusions. And I showed you in the previous slide that delusions can also occur in healthy subjects. So delusion is just a description that the awareness of the belief content is abnormal. And of course, it's not surprise for you, any type of aphasia severely impairs the semantic coding of belief information. So we have a very different, very differentiated way in which beliefs and the expressions of beliefs can be impaired by focal neurological diseases or more global neurological diseases, including psychiatric diseases. This is a simplified schema, but it highlights that the idea of a process model of belief formation and updating is viable for explaining these different types of abnormal beliefs patients can end up with. Now, as a reflection or a counterpart to the panel which I showed previously, which highlighted the different cortical brain areas related to the expression of beliefs, you can see here a very nice presentation in which it is shown that the so-called alien limb syndrome is brought forward by abnormalities in the brain that are more widespread and in particular involve a so-called prefrontal parietal network. The alien limb syndrome is a syndrome which can be observed in a number of neurological patients, particular patients with cortical basal degeneration, but also in patients with certain types of cerebral infarctions. So it's a syndrome at the behavioral level and is characterized by the feeling the patient has that an extremity, usually an arm, feels strange and unpleasant. And in above to that, it is not only it is not only a strange feeling, but it is all. It goes beyond that and also involves the delusion for the patient that the arm is steered not by themselves but by an alien, and this is the alien in the name, giving the name to this syndrome. Now you see on the right-hand panel that this is information taking basically from functional imaging and structural imaging and shows that there is an overlapping network involving the dorsolateral and dorsomedial, in particular parietal cortex, as well as the dorsomedial frontal cortex. And it's important to realize that this is a abnormality that involves both cerebral hemispheres. I would like to highlight this because the cortical basal degeneration is, at least in the beginning, a clearly lateralized clearly lateralized neuropsychological deficit. Now, a very recent paper, an Annals of Neurology, highlighted the notion of a spatial disorder which may occur after cerebral stroke. And you see the lesion overlap on the upper left-hand panel. You see the particularly spared area, which is relevant or significant describing these patients, which shows that a premotor parietal circuitry is involved. And on the clinical level, these patients have the delusion or belief that actions and objects are located in a different place as normal people think. Again, and this is reflected by the lower slide and the right-hand panel, these functional changes are connected or have to be seen as abnormalities that involve widespread cerebral circuitries You can see the medial aspect of the prefrontal cortex, including the supplementary motor area, and the precuneus, this is down in the middle, play a particular role. And this is of so great importance because those areas are related to cerebral imagination of information or mental concept building, or as Paul Fletcher coined it 20 years ago or so, as the mind's eye. Now, I'm virtually done. I just would like to give you a perspective concerning the influence of conceptual beliefs for societal life. And conceptual beliefs are very much underlined by the development of rituals. And rituals have a constructed occasion, so they have a narrative, and they provide an emotional loading of that what is experienced, involves learned acts, and go ahead with a high predictivity. So, such the close interaction of narratives that construct certain occasions and the emotional learning related to execution of learned acts with a high predictivity of future behavior are the major components that lead to the evolution of concerted social activity, as you can see here in this bonfire. Social actions are mediated by narratives, but social actions, interactions between subjects are very much also influenced by physical expressions. Pupil dilation, facial mimicry, gestures, body posture. These non-language related expressions of individual motor activity are very often the expressions of beliefs that a subject has arrived at. And this is very spontaneous, can hardly be modulated in a top-down fashion, allowing social interactions at an intuitive level. And this then may be taken a step further. When people become aware of that, what they are believing, they can phrase it, as I said, by semantic coding as narratives, and information can be exchanged between subjects in a two-person dimension, but also, of course, also at larger scales concerning communities and possibly also societies, in particular in our times when social media come into play. Now, this is the final schematic drawing, which I would like to show you to sum up what we have discussed so far. So we have on the left-hand side the environment, the physical environment of subjects as well as societies. And in this this level, in this environment, we can observe objects and we can observe events. And when it comes to societies, there are a lot of narratives around. On the other hand, we have the individuals, and the individuals are separate from that. So information is being perceived by the individuals, and this information pertains to objects, events, and narratives, as I told you. And this information then is processed to personal probabilistic representations that we may call beliefs. They may be taken and expressed as narratives. And these steps involve in making inferences about the causes of the information observed, allows us to do predictions of what is going to happen, and guides our actions and verbal expressions. But the important point is that we have to differentiate the inner processing in the individuals that is true only for the individuals, as compared to that what is out there and can only be perceived but also influenced by actions of the individuals. Now I sum up now. Belief formation and updating is something which pertains to the notion of tradition. Tradition is a concept that tries to explain what which processes underlie the formation of fluid beliefs, and that means updating of beliefs. And this notion then refers to systems physiology. I talked about primal beliefs. Those are empirical and relational beliefs, and these primal beliefs reflect the horizon of individual experience, and they are very much to the heart of cognitive neuroscience. I talked about abnormal beliefs, and I showed you that abnormal beliefs can occur in healthy subjects, but the patients with neurological diseases, with diseases of the brain, with psychiatric diseases of the brain, may develop abnormal beliefs which are caused by their specific lesions or dysfunctions, as we can study them in neuropsychology and psychiatry. I talked about conceptual beliefs, and I showed you that conceptual beliefs are brought forward in a very human, very human-specific manner by narratives, by verbal coding, and by rituals. And this pertains then to sociology, anthropology, and social neuroscience. And the final point I would like to make is that when we talk about belief, not about the processes of believing, but when we talk about a certain belief, be it an empirical belief, be it a relational belief, be it an autobiographical belief, a political belief, or a religious belief, then this is a post hoc attribution for a meaning which was might. And this is the level on which philosophy and theology come into action and have been worked over the centuries or since many, many hundred years. And I would like to thank you for your attention and would like to thank the organizations and foundations that allowed us to have a symposium, an international symposium on belief and belief formation last year in this beautiful palace in Hanover. This was sponsored by the Volkswagen Foundation, and right now there is a call for a research topic which will be published by Frontiers in Behavioral Neuroscience and Frontiers of Psychology with the title Conditions, and the content of this particular research topic is the interdisciplinary and international, I should say, approach to the nature of beliefs and believing. And I thank you very much.
Thank you. Thank you very much, Dr. Seitz, for such a beautiful lecture. We open the conference for questions, and in the meantime, I would like to introduce you to today's two panelists, Jesus Flores, Research Director of SOPENN, and Lucero Briana Cuevas, Director of International Relations, Linkage and Development. Before giving the floor to them, I would like to ask to you a question. That is, Dr. Seitz, in Peru, as in many places in Latin America, the Andean and religious belief is much stronger than the belief in medicine or conventional science, and how we could approach this type of patients.
I'm not quite sure. Are you talking about the general population, or are you talking about neurological or psychiatric patients?
Neurological ones, doctor, or psychiatric ones.
If I understood you correctly, you would say that there are far more patients that believe in religion rather than in medicine. Did I get this right?
Yes, doctor, because in Latin America, in some places, they have a very strong belief about the Andean culture, about religious belief that is more stronger than the belief in the medical, in the conventional medical treatment or anything else.
Yes, this is a very important question, and I'm happy that you have brought up this question, because I think this very much pertains to that what I tried to convey to you in the final slides, the huge implication of narratives and rituals for societies. This has something to do with the question how people are being brought up, and how religion and the natural sciences are valued by the ancestors of these patients, how this is being developed in a certain society with regard to education of young people. So you all know the interesting change of worldview which occurred at the transition between the Middle Ages and the modern times. Already Copernicus, for instance, modeled in a mathematical model, was able to show that we have a heliocentric system rather than a geocentric system. More than 150 years later, Galileo, using glasses, was able to prove that this mathematical model reflected the situation correctly. Copernicus was not taken to court because it was a mathematical model. It did not reflect reality, whilst Galileo had the proof in his glasses and said that what we can observe, the facts, reflect reality, and we have a geocentric system. So this has taken 150 years. And from there to modern science, to the development of modern sciences, it has taken another a long time, I would say. The development so it is a long way to make people believe, I should say, that the natural sciences have something to say, and provide an avenue on which care is can be founded. And this has something to do with the formation of beliefs, not only in individuals, but this transfer of belief contents from generation to generation.
Thank you, doctor. I suppose that is also important for the doctor and the psychologist in understanding of the sociology, philosophy, and the history of the work cultures, right?
Yeah, yeah, that is right. That is right. I would absolutely agree with that, what you're saying. I would like to stress in this context once more that um, the approach which takes the idea a bit further, that this approach is very much based on the idea that we are dealing with processes, neural processes that go on in the brain. So we are talking about believing, like perceiving and evaluating and so forth. Interestingly, this is something. This geronium is something which is particularly present in the English language, very much in contrast to the notion of belief. Belief is a result, and belief is a something which is called a belief by somebody else. So it is a result and is very static, has a complete different understanding as compared to believing, and takes it away as something superior, which is beyond or outside the brain.
Thank you, doctor. Jesus, Lucero, do you have a question?
Yeah,
Sure. No, go on, please, go on.
Lucero?
thanks. I love your presentation, doctor. We are glad to have you here with you. I have a question, doctor. To carry out the rehabilitation process of patient, should we change the response probabilities with the prediction error, so that the patient can have greater flexibility to respond?
That's a very good. This is a very good question that you pose, and I thank you for that, because this is something reinforcement learning, or learning from prediction errors, which refers to feed-forward modeling of information, is something which is very, in my view, very important for learning. For healthy learning, or learning in healthy subjects on one hand, and in particular also for patients. It is important that they act and make, and it is of less importance that their actions are not correct or go in the wrong direction. Then they have the chance to observe it and to correct their prediction error and to come up with a better result. So to include a prediction error into a rehabilitation program is certainly something which I would very much support, and I would say that this is something you should definitely pursue.
Thanks very much. Thanks very much, Doctor. And Jesus.
Yeah, it is a very interesting topic, and the most important part, I guess, about everything between the research and believing is that it has a huge amount of importance between the configuration of our behavior. And since we've been seeing in our culture, religion is the basis for that configuration. To have a better approach in the patient, for, of course, when it has a pathology and a neuropsychological pathology, it's very difficult for us since we don't understand at all the pathologies itself. Here we have a lot to development, and we have a lot to understand and research about the pathologies itself before we can understand how to properly approach to them. But an interesting And interestingly enough, a part about the presentation that I like and I hope to share with my partners here is that since we have this predictive pattern between belief and behavior, we can have a better understanding on how to approach to our particular patients by experience more than by science between the pathology itself. Let me explain myself. Since we know that behavior is configured in such a huge amount by the beliefs, we have to documentate and we have to understand better between with experience talking with patients or treating with patients with certain pathologies on how to approach to them. Maybe a certain type of pathology will have a stronger belief between political ideologies, or maybe another pathology will have stronger beliefs between religious patterns, as we saw with maybe schizophrenic patterns. We know that religion is very important in that kind of cases. We've seen around, or we've seen in the whole history of humanity that schizophrenia specifically has been treated as a religious problem in almost every culture. Here we have it as a problem with demons, as well as in modern Western culture that proceed with exorcisms between, I don't know, the 20th, which ended only in the 20th century, because we understood that it's not a problem of, let's say, supernatural forces, but it's more a problem of the brain itself. And since we know that kind of things, we know as well that the approach they had with these patients having this kind of pathology was based on the belief of religion. If we try to use that in our favor to better understand the patient and have a better approach to him, I guess that's the most important part of all this research, right? To understand the patient with the pathology and try to predict their conduct or behavior with the beliefs we know it has stronger developed.
Yes, I agree. I think this is very important what you say. This is I find this very interesting, as you say this, because you stress the aspect of religion so very much, again, as Rüdiger has done this as well, and there may be differences between the situations in the European continent and Latin America, I guess, as I appreciate from that what you are saying. And yes, there is interesting information showing that the contents, the belief contents of these narratives may be very may be exchangeable concerning the characteristics, depending very much on what is what is the target of the given person or patient. I would like to stress again that when it comes to organization of the brain, reorganization of the brain, pathology of the brain, we should rather talk about processes rather than representations. Because representations can be in different modalities, and they are connected by brain connectivity. And therefore I showed you these slides which reflected in fMRI data and structural magnetic resonance imaging data. We need to appreciate and we need to understand more clearly that functions of the brain are mediated by a number of cerebral structures. And the original idea, which was very much developed historically by pathological studies. Broca is one example, Wernicke is one example, that one circumscribed brain lesion results in a certain deficit. And then later, after the occurrence of the functional imaging data, and you remember this, the very first imaging data just showed you one activation in the entire brain, rather than this more refined pattern of blobs and functional circuitries that pop up today. So we need to understand the brain in a far more differentiated way, such that we take into account specific nodes, particularly involved nodes, and the connectivity in between as well. And lesions or neurological diseases disturb this communication between different brain areas. And this then may result in a panel of abnormalities. And so far, and this can be studied in individual patients by dedicated neuropsychological testing very well. But this is the way we need to go to be more differentiated, and also to take into account, not to forget about it, the temporal domain of information processing in the brain.
Yeah, of course. And interestingly, though, we know that with cerebral damage, specifically in the frontal cortex, it's surprising that we have a whole new patient. We have different resulting tests of personality and everything.
Yeah.
And even with that, and leaving that aside, we have different syndromes like Clover-Bessie that freeze our behavior from our self-restrictive personalities, or even for the socially acceptable behavior that we like to maintain in every society or every culture. And as you said, when we study the brain and we understand fully that it becomes, or the origin of these changes is physiological cerebral damage, is what we kind of focus on, and we don't understand yet at all. It's amazing. It's truly amazing. Oh, we have my teammate here, Francisco de Jesus Garcia, with the raised hand. So, Paquito, please go on.
Thank you, Jesus. First of all, I want to say thanks a lot, Doctor, for your excellent lecture. And I have a question about there is a disease called Capgras syndrome, where the patient thinks that a familiar or a friend have been changed by another person, like a substitute. So it's amazing how some diseases or some damage in the brain can cause a change in the reliefs. So in how much this disease or something like that, or some disease similar, can change her relief? So what do you think about these changes?
Yes, a very important point, and good that you mentioned that. We referred to this in our paper as well. And I think the anatomical substrate of Capgras syndrome has not fully been recovered now, but at least what we can say is that the lesion is very close to the visual to the area which processes visual information, which allows us to identify faces and emotional face expressions, and then value this information. So I think it's a very interesting presentation Unfortunately, I have not seen personally a patient with such a psychiatric delusion. I've seen a number of patients with different types of prosopagnosia, but not this particular delusion. So, but this is due to the fact that I'm a simple-minded neurologist and have, for that reason, possibly not had the chance to identify this. Possibly also, it is very rare. I think for the patients that have been described that these deficits are very rare. And therefore, I found the publication so interesting with the spatial delusion after stroke. This is something, this is my personal mind reading out of that. Stroke, hemispheric stroke in the medial artery territory is very often, but you need to look for abnormal perceptions in those patients, definitely to identify it. And I think such delicate changes very often are overlooked simply, and we should be far more diligent and far more careful in evaluating our patients with concerning the panel of differences after a focal brain lesion. Yes, I agree with you. Very important.
Thank you, Doctor.
And also, I was reminded by what Francisco said, that in one of your slides we could see alexithymia, which, oh my God, it's one of our biggest questions yet to treating or to approach to a patient, because all we know about memory, all we know about connections between your predictive pattern in behavior usually tend to go between emotion and memory. And with alexithymia, which they cannot fully understand what they are feeling or what their emotions are, it's very difficult for us to understand how we should approach to that kind of patient. And if that is with one kind of agnosia that we were seeing with alexithymia, I was thrilled to know if you have the experience treating with a patient with other types of agnosia, and how is usually the procediment to take the prediction of their behavior, or they have a pattern in behavior with some certain kind of agnosia.
Yes, this good that you mentioned that. Just to start off with the alexithymia, this is something which can be tested specifically, and I would like to refer to the Toronto alexithymia scale, TAS 20. You may be aware of that, so you can really score and screen your patients for that. And we had the chance to see patients of that sort, stroke patients, by the way, and we looked into that. What came out of that was that these patients very much have problems or lesions in this those examples of the medial frontal cortex, probably involving the cingulate gyrus and the also the pre-supplementary motor area. Now, concerning the abnormality actions in patients with agnosias, this is a very interesting topic. I would like to take the example of astereognosia. This is the inability to identify objects that are given to you in your hand just by touching them. These patients cannot, for instance, tell you that this is a coin or a rubber gum or a key or something like that. Although they are able to realize that this is cold as metal or rough or so, but they cannot construct the three-dimensional geometric configuration of this particular object. What is interesting, and there is the relation to action, that these patients, as they are unable to identify these objects, they are also unable to handle these objects. They have severely deficient motor patterns in relation to using these objects and to exploring these objects. And thus there is a very close relation of sensory perception and action generation in the term of agnosias.
It is extremely interesting to me that they are able or capable to understand the texture or the material without knowing what the object actually is.
It's very interesting. It again shows how delicate the brain works and how carefully one need to examine the deficit of such patients, because you are then able to pinpoint a deficit, and this is the good, sufficient then to correlate this with abnormalities of cerebral activity patterns and connectivity.
And once again, looking at it from the belief part of it, I cannot realize what I believe about something if I cannot identify what I am handling, right? And in this case, if I want to work with a patient, specifically with this kind of agnosia, what kind of procedure should I do, or what kind of help can I provide to them in order to help them be more functional or have a better understanding of how to handle things without needing to identify them?
Yes. In terms of rehabilitation, it is probably the best way to supply the patient with as much information as possible in different channels, so that they can develop a strategy to use cross-modal information processing to build up a new internal representation. This is the usual way of ontogenetic development. The point is that this is a long-lasting endeavor, and patients should be alerted to the fact that this is long-acting and long-lasting, and then they need the encouragement, the excuse me, the positive effect related to the information they are processing, that this information means something for them. And as soon as this connection has been done, then we are very close to this, the idea that the patient trusts or believes what he perceives or she perceives. As soon as this is done, memory formation becomes easier.
I understand. It's like adapting, right? Like if I was blind, I should take other kind of stimuli to understand better my environment.
Yeah, right. Yeah.
But what if a certain event truly marked myself as a person, as it helps me gain my beliefs, but I had amnesia and I forgot that specific event that helped me develop basically my beliefs, my strong beliefs? How would a patient with that kind of characteristic would react, or how a person would react between that that kind of experience?
Yes, yeah, very interesting, question. HM, you are probably aware of the patient HM. He maintained his beliefs until he fell ill. So he's was stuck to his beliefs that he developed earlier. Because of amnesia, he was not able to build this up by new beliefs, or not able to update his old beliefs because he had this amnesic problem. So this is a very fundamental problem indeed. I must confess that I don't know how to compensate for that.
No, it is totally understandable. I mean, we have a lot of research to do in the topic, but
exactly.
would you say it would be accurate to affirm that that the brain holds so tightly to a previous stimuli because it has the necessity to have a belief in order to have a certain behavior, or in order to have behavior itself?
Yes, it is. The evidence must reach a certain threshold that a belief can be modulated. But I think we should rather stop thinking that beliefs are static. We update our beliefs all the time, but still there may be, and this is particularly true for conceptual beliefs, but when it comes to primary beliefs, which develop below our level of awareness, and that very often, or in the majority of instances, cannot be labeled semantically. I guess this is something which makes it very difficult to change these beliefs, and this is usually the case that people stick to their pre-disease premises or beliefs. Yeah.
I understand, Doctor. It was truly a pleasure to being able to talk to you, since we read the article and we were so amused by this kind of study, right? Because we have a lot to discover yet, and these are the huge steps. So I want to thank you for being for having the courage to take that step, since we know we are in a scientific field where if you take a bad step, you fail, and you fail hard, and it can hurt really bad. So thank you again, and I want to share with you the admiration we have as a society for you, for this kind of braveness to do this kind of research. So thank you very much for your research and for being here.
Thank you very much. It was a real pleasure for being there, and it was a pleasure for presenting, but in particular, I enjoyed very much talking to you and exchanging ideas. Thank you so much.
Thank you, Doctor.
Thank you very much, Doctor. From SOPENN, we proposed the scheme of the multidisciplinary team to care for the neurological and psychiatric patient. We seek that the idea of a team of the mind be integrated from the university students. Everyone in the society is a student of medicine or psychology with a strong interest in neurosciences, as you can see. You have Dr. Seitz final words for our audience.
Yes, thank you very much again. This was very enjoyable. It was a pleasure to present, and it was a pleasure to meet you in person. And I think it's a fantastic development which has taken place due to the COVID pandemic, that we developed these tools that we can meet at a global level and exchange ideas, meet nice people. And so thank you very much for inviting me. I enjoyed it very much.
Thank you, Doctor. Thank you very much. We hope to have your support in future projects. And thank you all very much for the audience. Thank you all. Thank you, Francisco, Jesus, Lucero. We hope to see you in the another lecture. Thank you. Goodbye.
Thank you. Bye-bye.
Muchas gracias. Hasta luego.